the overall exam is going to cover chapters 10, 11, and 12, but only the sections of 12.1 and 12.4. We did not cover 12.2 and 12.3. So looking at chapter 10, really the big things we talked about were exponentials, so exponential equations, and graphs, logarithms, and then the interest formulas. And these are kind of going to be the bulk of what comes from chapter 10. Okay, so, one last thing. And also the idea of this inverse graph, either doing it algebraically or like you saw in the quiz. So working out, let's actually start with that last one with the inverse. And so we have two versions of this, which is I ask you to find the inverse of an equation, or like on the quiz, I ask you to find the inverse of a graph. So looking at the inverse for an equation. Let's say given f of x is equal to x plus 4 all over 2x plus 1. And I ask you to find f inverse of x. So the way we did this algebraically was we wrote this in terms of a y equals equation. That's just rewriting the same original equation. And then what makes it an inverse is we're going to do this swap of variables. So swapping will make x equal y plus 4 all over 2y plus 1. And that's the initial step. And the goal, as we always do, is to set this up in the form of y equals some equation. So we need to solve this thing for y. And as always, when we have these kind of rational expressions, we can either multiply it by the denominator. The other thing we can kind of treat this as a cross multiplication. So doing that cross multiplication would leave me with y plus 4 is equal to x times 2y plus 1. All right, doing our algebra of distributing. So we have y plus 4 is equal to 2xy plus x. And this last step is since we want to solve for y, what I'm going to do is I'm going to subtract the x over and also subtract this y over. I want the y's on the same side and the single x to get moved over. So when we do that, we're left with 4 minus x is equal to 2xy minus y. And we see that both of these have a y in common, so we can factor that out. And then the last step is just to divide over. So 2x minus 1, 2x minus 1. And so we're left with y is equal to 4 minus x all over 2x minus 1. And this is technically our inverse equation. So this is kind of the hardest scenario. You had a couple ones, and these are technically fair game, which is like just a simple linear equation where we just have to move some variables around. But this is kind of the worst case scenario, which is why I wanted to go through this one. Okay, any questions on this, anybody? Okay, so doing a similar thing for graphing. I'm going to kind of work one out that's very, very similar to what we did, what you guys did on the quiz. Something like this. So one of the graphs that you guys saw, a little bit something like this. In kind of this curved equation. And you were given this as f of x, and you were asked to graph the inverse, which I'm going to call f inverse of x in red. So we're going to do the exact same thing more or less we're doing with algebra, which is we're just going to switch x and y. So what that requires is first I'm going to find the points of f of x, and then I'm going to switch them to write the inverse out. So if we look here, I have the point 1, 0, 2, 1, and 3, 2. So the inverse says that we're just going to switch x and y. So for my x's, I'm now going to have 0, 1, 2. And for my y's, we're going to have 1, 2, 3. So now what we're going to do is plot these points. So we have the point 0, 1, 1, 2, and 2, 3. And we're going to have the same kind of upwards curve like we had before. So that is graphing the inverse given a graph without any equation attached to it. Okay. Questions on this, anybody? Alrighty, so that's in terms of all the inverses. The other thing we can kind of talk about is so looking at exponentials, both equations and graphs. Let's look at an exponential graph first. Let's say I give you the equation of y is equal to 2 to the x plus 1 minus 2. Okay. So the important thing and where we always want to start off with is remember that all exponential equations have a horizontal asymptote. And that's always going to want to be the first thing you want to graph. So in this case, it's going to be given by this kind of subtraction part, the part that's outside of the exponent. So in this case, because it's a minus 2, that means we're going to have a horizontal asymptote of y equals negative 2. So we can kind of slot that in. And now what we're looking to do from here is plot the graph. So all I'm going to do is just plug in some values in for x and just evaluate them. So 0 and 1 are usually good numbers. Once again, test them out. If they're too big, move around a little bit, but let's just see what that gives me. So that's going to give me 2 to the 0 plus 1, 2 to the 1 minus 2, which is just 0. And if I plug in 1, that's 2 to the 1 plus 1 minus 2, or 2 squared minus 2. Well, that's 4 minus 2, which is 2. So we have the point 0, 0, and 1, 2. And the way an exponential graph always works is one side's going to move away towards the asymptote. The other side is always going to move towards the asymptote. Okay, so this would just be an example of just a quick and easy graph of an exponential equation. Any questions on this? All right. So that is the solving, that is the graphing of exponentials. The other thing we talked about is solving exponential equations. So something like, we basically had two forms. Which is ones that could be simplified to a common base and ones that couldn't be simplified to a common base. So just as a note, a couple people did this in your work. What you can't do, and this is, I'll do this in red and then probably erase it because it's bad. You can't do this where you say, oh, this is like 3 times 9 to the 3x. You can't pull out a multiple because pulling out the multiple, this is still going to have the 3 to the x attached to it. So we still don't have this common base in between these two. So the only thing we can kind of do is break this up as powers of the same number. And knowing our squares and our cubes, we know that 9 can be written as 3 squared, the 2x minus 1, and 27 can be written as 3 cubed, to the 3x. So what that's going to give me is 3 power to a power, means we distribute. That's 3 to the 4x minus 2 is equal to 3 raised to the power of, once again, multiplying those two together, 9x. And once it's in a common base, we can actually drop this entirely and just look at the exponent of 4x minus 2 equals 9x. And now we just have a very, very simple linear equation to solve. We're left with negative 2 is equal to 5x, and we're dividing out. We get x is equal to negative 2/5. So this is the case where we have a common base in between them. Questions on this, anyone? This is kind of, I think this is probably the easier version. So always see, once again, if you can find a common base. And if you can't, if we have something where there's no common base, something like this, 9 to the 2x minus 1. It doesn't take much for me to break this. I literally just make that a 26 instead of a 27. Now this is something that we have to work out with logarithms. So if there is no common base, the way we get around this is using logarithms. So we can either use log base 10 or the natural log. Remember that they both work because they're both plugged in, they're both set into my calculator, so both of these are valid. So if we do work this out, I'm going to use log 10, so I'm just going to use the common log sides. So what that does is, remember, using properties of logs, that's going to pull that out front as 2x minus 1 times the log of 9 is equal to 3x times the log of 26. And once again, if you want, you could turn these into decimals and distribute in, but something that I like to do to make this look a little bit nicer is I'm going to divide both sides by the smaller of the two logs. Once again, this is entirely preference. You don't have to do this. You can skip this step. But I think what it does is it does make this look a little bit nicer. So we have 2x minus 1 is equal to, on the right-hand side, 3x times, and if we calculate that, log 26 divided by log 9. Going out a couple decimal places, that's going to give me 1.483. So now we can just multiply that in. Say 2x minus 1 is equal to 4.49. Sorry, 4.449. X And now fairly straightforward. We're just going to subtract the 2x over. So we have negative 1 is equal to 2.449. And then lastly, we divide out. Get us an answer of x is equal to negative 0.408. So this is the other version of these exponents.
You can try to bite her. Mama Nina's biting the Gracie.
Okay. Questions on that, anybody? All right, then. So those are the exponent equations. The other form we talked about, and the other things we're going to have to, I'll ask you to do, is to calculate the logarithms. And there are a couple of questions I can ask you for in terms of logarithms. The simplest is just, I could ask you to evaluate something like, what is the log base 12 of 100? Now, once again, if there's a way to get an exact power, feel free to do that. But for a lot of these, this is where we're going to want to use the change of base formula, which says that anytime you have the log base b of x, we can rewrite that in terms of the common log base 10 of x divided by the common log base 10 of our base. Or if you like to use the ln better, you can also write this as ln of x over ln of our base. And these are both programmed into our calculator, so this allows me to get an exact decimal answer. So we work this out as, I'm just going to use the natural log version, natural log of 100 over the natural log of 12. So we work that out, we end up with 1.853. So this is just using that change of base formula, good thing to kind of have on a, once again, cheat sheet. Right. So that's just, those are kind of the easy, give me multiple choice problems, in and out, 30 seconds if you know what you're doing. The other thing we want to look at is the properties of logs. So the three big ones we've already used one of them already, but in general, if you have a multiplication inside of a log, you can break that up using addition. If we have division inside of a log, we can break that down in terms of subtraction. And if we have an exponent inside of a log, as the one we used earlier, you can pull that power out front to make it a constant multiple. Also, just as a general rule of thumb, when we're talking about the log of x, in general, this works for any, it has to be the case that x is strictly greater than 0. We've talked about this, and we can kind of throw a quick little graph up. What happens in general for a logarithm, once again, I'm not going to give you these by hand, but you should probably know some properties. I could ask you like a multiple choice question about some of this stuff, which is like, what is the domain of a specific log function? Or I could ask you to kind of match an equation to a graph. So in general, if we're looking at the log of x, that has a vertical asymptote at 0. And it looks a little something like this. which is we have that same thing, which is one part of the graph moves away from the vertical asymptote, one part of the graph moves towards the vertical asymptote. Here, in this case, we have a vertical asymptote. All right. In terms of some log properties. Right as a single logarithm. So we have two of our things going on here, which is we have a subtraction symbol, and we also have this coefficient of 3. So I'm going to deal with that first, which is that 3. Remember, we can bring that in as a power. That's the natural log of, so we're going to take this entire thing, which is x cubed, y to the 7th, and we're going to raise that to third power. And then we're still going to have the second log of ln of x squared, y to the 10th. Plugging that power in. Well, remember, x cubed to a third power, we multiply. It's going to become x to the 9th. And y to the 7th cube is going to give me y to the 21st. And the last step is we're going to use the fact that subtraction leads to a division. So this is the natural log of x to the 9th, y to the 21st, over x squared, y to the 10th. We can do a little bit of simplification here, where we divide out those x and those y's. So x to the 9th over x squared leaves me with x to the 7th. And y to the 21st over y to the 10th leaves me with y to the 11th. And now we've written this down as a single logarithm, which has been simplified algebraically. That's going, we're making it smaller. The other one is to expand out. Something like this. So we have the log of the square root of x times the cube root of y, all over w to the 7th times z. So when it comes to logarithms, we always want to write everything in terms of exponents. So that's going to be my first step, is to change these square roots and cube roots into a 1/2 power and a 1/3 power, respectively. And we're going to keep the powers of w to the 7th. And technically, if you want to write that as either first, you can. It doesn't really matter in this case. So now we're going to break this up. So we have the multiplication up top, and we're dividing by these two things on the bottom. The general rule of thumb is if you're multiplying, it's going to lead to addition. So this is going to be the log of x to the 1/2 plus the log of y to the 1/3. And since we're dividing both the w and the z term, both of those are going to be subtracting. Subtract the log of w to the 7th. Subtract the log of z. So we're almost done. The last step is I have these exponents here. So we're going to take those guys and pull them out front. That's going to give me 1/2 log of x plus 1/3 log of y minus 7 log of w minus the log of c. Questions on this, anybody? All right. So that's it for in terms of the properties and techniques. Really, the last thing I could ask you when it comes to the logarithms is to just solve equations using logarithms. So something like, now let's go to the next page. Something like this: log base 5 of x plus 10 minus the log base 5 of x equals 2. So what we're always looking to do with these is combine our logarithms. So usually we'll do some properties of log like we just did. And this minus means that we're going to set this up using subtraction. So log base 5 of x plus 10. Subtraction means that we have division. So that means we're going to write this as over x is equal to 2. And we saw this happen a lot. What's our next step? Well, in general, if I have the log base b of x equals y, we can always rewrite that as an exponent form of b to the y equals x. And that's how I'm going to work this out. So I'm going to rewrite this as 5 to the 2 is equal to x plus 10 over x. So we square on the left-hand side. And now, once again, we are back to a fairly straightforward rational equation. We're just going to cross multiply here. So we get 25x equals x plus 10. Subtract our x. And we have 24x is equal to 10. And we divide out. And we get x is equal to 10 over 24, which simplifying down leaves me with 5 over 12. Now, the one thing we always have to do with logarithm equations is we have to check and make sure that we have no negatives in the actual plugin. So, if I take this 5/12 and plug it back into the original equation, that gives me the log of 5/12 plus 10 minus the log of 5/12 is equal to 2. And I do not need to go through the full check and actually make sure that they're equal. I just need to see, okay, those two numbers, whatever they are, it's a positive fraction plus a positive number. That'll be positive. Likewise, 5/12 is positive. So we do indeed have all positive values, which means that this is my final answer. Questions on this, anyone? All right. Let's do one that has a plus. All right. So here we have a case where we have a plus in between, so that means we're going to break this into a single term where we multiply. So we're going to have x plus 3 times x plus 2 in a logarithm, and that's going to equal 1. Distributing that out, it's going to give me x squared plus 5x plus 6. And just like we did before, we're going to rewrite this as an exponent equation. So it's going to be 2 to the first is equal to x squared plus 5x plus 6. So 2 to the first, well, that's just 2. So we have a quadratic, so zeroing out one side, like we do with all quadratics, leaves me with x squared plus 5x plus 4. So quadratics will come back up on this exam. Once again, we either can factor them if they factor, or quadratic formula. In this case, we can actually factor this one down. 4 and 1 multiply to 4 and add to 5. That means that since we have a 1 in front of the x squared, we can factor that into x plus 4, x plus 1. So we get our values of x equals -4, x equals -1. So we have both negative values. That's not necessarily bad, but we have to check to see, does plugging these back in cause a negative value? So if we look at x is equal to -4, that gives me the log base 2 of -4 plus 3, plus the log base 2 of -4 plus 2 equals 1. Well, -4 plus 1 gives me, -4 plus 3 gives me -1. -4 plus 2 gives me -2. So I do have a negative inside of a logarithm, which means this one does not work, which means x equals -4 is not a solution. If we look at x is equal to -1, that's the log of -1 plus 3 plus the log of -1 plus 2. And here we are left with +2, +1. Both those are positive. So this does check out. So x equals -1 is my final solution. Okay. Questions on this, anybody? All right. The last little bit from chapter 10 are just our two equations. Once again, good things to have on a little cheat sheet of compound interest and continuous interest. So compound interest formula and the continuous interest formula. So make sure you have these written down somewhere. I will not be giving these to you on the exam. It's up to you to know, have them on you and to know when you need to use them. So just some quick examples, two straightforward ones. Let's say we have $3,000 in an account at 4.2% compounded quarterly. How much will be in there? How much will be in the account? After 5 years. Okay, so since I actually told you how often we were compounding, that means that we're using the initial compound interest formula. So we're asking for the final amount, so the unknown here is A. And then we're just going to plug in. So we have 3,000 times 1 plus. My rate here is 0.042 divided by, since we're compounding quarterly, that means we're compounding 4 times a year. We're going to raise that to the 4 times 5. Now this is really just becoming a calculator problem. Just make sure you're careful when you plug in. So this is 3,000. And then this is 1.0105. Make sure you keep track of your zeros. Tell people lost a couple points in the quiz simply because they did not, pardon me, simply because they lost track of a zero. And then 4 times 5 is raised to the 20th power. And then now we can just chuck this in the calculator. That's going to give us $3,696.98. There's the compound interest formula. The other question I can ask is to go backwards, which is, let's say we have $3,000 still at 4.2%. This time we're going to do it continuously. And the question we want to ask is, how long will it take to double? Okay, so we're doing continuous interest. So A is equal to PE DRT. So since we want to double the value, I know that my A is going to be 6,000 because we're doubling. My principal is 3,000. Then we have E, the rate is 0.042. And we don't know for how long, so that's my unknown variable. So here we're working backwards. We know how much we want to know how long it's going to take to get there. And for all of these, the trick is going to be the same, which is first we're going to divide out the constant coefficient. It's on the left-hand side, we're just left with 2. And just like before, we have an exponent equation, so we can either use the log base 10 or the natural log. In this case, you really want to use the natural log because since we're in base E, that's going to cancel out very nicely. So I'm going to take a natural log of both sides. So we have the natural log of 2. And since ln and E have the same base, they just cancel out. I'm just left with 0.042. That's it. Times B. So then our last step is just divide out and check it in a calculator. That gives you about 16.504. And that's going to be what we always measure money in, which is 0. All right. Questions on this? Anybody? All right, that's chapter 10. Chapter 11. This is all of our graphs. So we have the circle, we have the parabola, we had the ellipse, and we had the hyperbola. So those are all the graphing things. And then we also had systems of equations. I'm just going to run through an example kind of working with all of these, kind of going through some pieces. And like I said, we'll go both ways, which is sometimes I'll give you the equation, you give me a graph. Sometimes I'll tell you a piece of information and ask you to give me the information.
I have a question.
Go for it.
Will there be an online graph?
Yeah, so what I'm going to do for that is there is no way for me to program the graphing software that we use on the homework into Canvas. So what I'm going to do is there's going to be a PDF, and I will link it. And it's just basically going to be a piece. It's going to be a PDF with just a bunch of these blank graphic squares. So if you have a printer, you're welcome to use that, or a couple people use like online tools. They'll do like kind of what I do here. They have like an online whiteboard and they do their work in there. You can just load the PDF into that program. If you do not have access to either one of those, you're welcome to just kind of draw your graph axes by hand. And once again, I will kind of, grade those a little bit on a curve. Like once again, just like as we've seen before, I can't draw a nice pretty circle to save my life, except actually that one's not too bad. So it's not going to be a thing where it's like, if you're a little more oblongy, you kind of screw up your circle a little bit, as long as you're within the ballpark, you're going to get full credit on this. So I will be posting that file for you to have. It's going to be under the Files tab, and I'll put an announcement up once it goes up. I'm going to be putting it up right after class today. So if you want to print that out, you're welcome to. If you don't have access to a printer, you can always still just draw your graph by hand. Okay. So let's start off with the circle. And I talked about this last class, but in general, you can kind of treat all circles as ellipses, but if you want to separate them out as two separate things, we can do that. So an example would just be, all right, give me a graph of something like x minus 2 squared plus y plus 3 squared is equal to 4. Now we plot that. The two things that define every circle are your center and your radius. So remember that we always have to switch these up. So I have -2 and +3. So that means my center is 2, -3. And that the radius, well, remember this is r squared, so we want to take a square root of that. So I have a radius of 2. So plotting that over here, my center is at 2, -3, which is located right here. And then for the radius, once again, once we're doing this by hand, the easiest way to do that is we're just going to go 2 points in all directions. So up 2, right 2, down 2, left 2, and then we're just going to draw our best circle. Once again, this looks like a circle that's seen some shit. It's kind of garbage. This would be worth 100% credit. Because really what I'm looking at here is your center correct? Are these 4 points correct? And so long as that's all good and you did your best to try and draw a circle, this is going to be worth full credit, even if it's not exactly perfect. I don't need you to go out and get a protractor and a compass and actually give me perfect circles. Okay, questions on this? All right, so going the other direction. Find the equation of a circle with, there's no E in with, a center at the point 4, 6 through the point 1, 2. This is where I give you the information and we're going to plug in to get our circle. So the two things we need to know, and just bringing back the formula one more time, is the center and the radius. So we have plugging that in, that's very simple, which is just x minus 4 squared plus y minus 6 squared is equal to, well, we don't know the radius yet. So if we think about this, we have this point 4 comma 6. Once again, just kind of throwing this out into space. Here's 4 comma 6. That's my center. And I know I want to go through this point 1 comma 2. So I draw my circle. What we need to find is that radius distance, which is just the distance from the blue to this red point. So this would be an example of us using our distance formula. Okay, so plugging into our distance formula. Once again, writing that down because it's been a while. Oh, actually, technically, the exact way was x2 minus x1 squared plus y2 minus y1 squared. All right. So plugging in my points, so we have the center of 4, 6 and the point 1 comma 2. So that means we're going to have the square root of 2 minus 4, sorry, pardon me, 1 minus 4 squared plus 2 minus 6 squared. 1 minus 4 is this is 3 squared plus 4 squared. The square root of 9 plus 16. Square root of 25, which is just 5. So now we have our radius. Remember that we always square it when we're plugging it into the equation. So your final answer for this would be x minus 4 squared plus y minus 6 squared is equal to 25. All right. Questions on this? Anyone?
Does it have to like absolutely be squared at the end in order for the answer to be right? Or would either or be taken as correct?
Wrote it as 5 squared or 25.
Yes.
Yeah, I'm like, I will say, if this came up as a multiple choice, it would definitely have the 25 version. I am not gonna, I don't care. If you write those, I'm okay with either one of those. That's fine.
Okay, thank you.
Any other questions? Okay. That's more or less everything we wanted from the circle. Next up, the parabola. And we're going to be looking at parabolas that are horizontal, which means we're either looking at things that look like this, or something like this. So the standard form and the vertex form. And we'll do an example of both of these. For the standard form, we're always going to do what we did before, which is negative b over 2a. But just be careful that this is going to give me the vertex of the y coordinate. Likewise, if we look at this, this is going to give me my y coordinate and my x coordinate respectively, because we have this backwards when we're dealing with y functions. Okay, let's look at one of these. So here we have one in the standard form, which means that we're going to write this as the y coordinate will be given by negative b over 2a, which in this case is negative negative 12 over 2 times 3. So the negative cancels, so we have 12 over 6. This gives me a y coordinate for my vertex of 2. In order to find the x coordinate, we're going to plug that value into my equation. So we know that x is equal to 3 times 2 squared minus 12 times 2 plus 8. And if you work that out, that gives you x is equal to negative 4. So now we have a vertex. All right, so plotting this on a graph. Negative 4, comma 2. Right here. Remember, we are going to have this horizontal line of symmetry because we are a horizontal parabola. So now what we need to do in order to finish this graph up is we need just one other point on either side. I always like to pick points that are nearby, and remember we're going to be plugging in for values of y. So if we are at y equals 2, the value that's close by would be y equals 1. We'll use that as my second point to plug in. So that would give me x is equal to 3 times 1 squared minus 12 times 1 plus 8. Which just gives you a value of negative 1. Or sorry, pardon me. Yeah, negative 1. So be careful once again that this is the point negative 1, comma 1. Make sure to keep your variables straight. So negative 1, comma 1 puts me right here. And then we're just going to mirror over. So if I have negative 1, comma 1, if we have 1 point below, I have exactly a point on the other side mirrored up. And now, once again, to the best of our abilities, we're going to kind of hand draw this parabola in. And there we go. Okay, any questions on this? Alrighty. So here's an example of it in the standard form where we need to use this negative b over 2a. Similar thing I could ask you for is just to write one out, given it to you in vertex. So something like this. Once again, I think these are actually a little bit easier problems. The thing you really have to keep track of is, I can't stress this enough, the mistake everyone makes. If you're going to make a mistake, the mistake people tend to make is they just get x and y reversed up. That's the most common mistake. So if you just keep that straight, I really can't do anything to screw with you. These are fairly straightforward if you can keep everything straight in terms of variables of x and y. Okay, so for my vertex, we have that the y coordinate and the x coordinate is positive 2. So plotting that to negative 1 puts me right there. And then just like before, we're still going to have this horizontal symmetry through that point. Now all we have to do is just plug in another point. So once again, we're looking at the y value to plug in if I'm at negative 1. Want to pick something nearby? 0 would be a good choice here. So that would be -3 times 0 plus 1 squared plus 2. So that's 1 plus 2. So that gives me the point -1. So that gives me the point -1, comma 0. All right, so plotting that point, -1, comma 0. It's right here. Just like before, I'm going to mirror that over on the other side. And then draw our graph. Alrighty. So these are both versions of the parabola. These are really the only questions I'm going to ask you when it comes to the parabola. Like just these two, being able to graph it either in the standard form or the vertex form. That's it. Questions on this? Anyone? All right. 2 down, 2 to go. For the ellipse. So, H, pardon me. Important things to remember when we're dealing with the ellipses is that these are like circles and that they have a center, but the vertical and the horizontal distances are not equal. So the way we split that up is we always make sure we divide out, make sure that this right-hand side equals 1. And when I do that, those are going to give me these two fractions of A and B, which is going to help me break this down in terms of how far are we moving left and right, how far are we moving up and down from my center. Now, these can be a little bit broken up. Once again, we've seen if they're in the nice compact form, these work very similar to the circles, but something we can also have is have these fully expanded, so something that looks like this. Which is I ask you, I mean, there are a lot of questions I could ask you. I could ask you to graph this if it's a free response question. If it's a multiple choice, I could just ask you to like find the center and the values for A and B. That'd be a good multiple choice way to ask this question. Or it could be a very simple one where maybe I give you this equation, I just ask you which one of the 4 shapes do we have? And for that one, you don't even need to do any sort of algebra. Remember that really, the options are, if one's squared, it's a parabola in terms of x and y. If they're both squared, it's either a circle, an ellipse, or a hyperbola. Looking at this, we see that the x and y are not equal, so boom, circle's gone. And since both x and y are positive, that means that without doing any sort of algebra, I know that this has to be an ellipse. Just kind of process of elimination. And that'd be a good, very quick multiple choice question. Just like looking, and it really doesn't even require any algebra. Once again, you can just kind of eyeball this, and without doing any sort of calculations, there's one and only way that this can break down, which is the ellipse. If I ask you for some more information, this is where the algebra needs to come through. So in order to get this into my nice form, we're going to have to complete the square. And we're going to have to do this twice. One's for x, one's for y. So the first step I always like to do is pull out this 37 and move that over to the other side. So we have y squared plus 6y plus our blank is equal to -37. And then the one thing we have to be careful about is I have this, I'll do this in blue, this 4 here. We need to have a 1 in front of our squared term. So what I'm going to do is I'm going to factor out that 4 out of both of my terms. That's going to leave me with x squared minus 8x, and that is where we're going to have our blank spot for completing our square. And now we have this set up, so we're going to do our completing of the squares. So we have 2b is negative 8, which makes b negative 4. So b squared is 16. So I'm going to put that 16 in there. We need to copy that over to the other side, but since we have this 4, we need to multiply those two pieces together, and 4 times 16 is going to give me plus 64. Make this equal on both sides. Next step, completing the square on y. We have 2b equal to 6. So b is equal to 3. So b squared is equal to 9. We have no multiple here, so whatever I put in that blank spot there, I'm going to put exactly on that blank spot on the right-hand side. Okay, so finishing this up. In blue, we're going to have 4. My value for b is negative 4, so it's going to be x minus 4 squared. Closer. Plus, looking at the y value, the b term had a 3, so it's going to be y plus 3 squared. And on the right-hand side, we have negative 37 plus 64 plus 9, which gives you a value of positive 36. Okay. Like we said, we want to make this right-hand side always equal 1. So I'm going to divide everything through by a 36. We're going to simplify some fractions and be left with, this is going to become x minus 4 squared. 4 over 36 simplifies down to be 9. Plus y plus 3 squared all over 36 equals 1. And now we've broken this down into the form that allows me to see what my center is, what my horizontal distance is, what my vertical distance is. So now we're just going to draw this on a graph. All right. So first we're going to look at the center. The center in this case is going to be positive 4. Excuse me. Flipping the signs, positive 4, negative 3. And then we're going to find our a values, a and b values. So here we have a squared is equal to 9. So a is equal to the square root of 9, which is 3. That means we're going to move left 3 points. So 1, 2, 3. Right 3 points. So 1, 2, 3. And we have that b squared is equal to 36. So b is the square root of 36, or just 6. Which means that from my center, we're going to move up 6 and down 6. So here's up 6. Here is down 6. And now we just connect our points with the best ellipse we can draw. And here we have the full problem, where we have to complete the square, and then from completing the square, we graph the ellipse. Any questions on this? All right. Working this one, like I said, I can give you the other direction, which is I can ask you to give me an equation given a particular graph. So let's look at one of those. Let's say we have something like this, where all I do is I just give you a picture, and I ask you to tell me what is the equation that gives me this shape. All right, so once again, I have my general form for an ellipse is x minus 8 squared over a squared plus y minus k squared over b squared equals 1. All right, so working this out. First, we need to find our center. So the center of this is right here. We've already got that filled in. So this center here is 2, negative 1. That's my center. We can plug that in. That's going to be x minus 2 squared plus, it's going to be y minus minus. It's going to be y plus 1 squared. And we're just going to plug in our values for a and b. So we see that in terms of a, that's the horizontal distance. We're moving left and right 2 units. That's going to give me 2 squared here. And then in terms of b, we're moving up and down 3 units. So we're going to have 3 squared right here. And if someone asked before, can I leave it in the squared? If you're doing this on a free response problem, you can stop right here. This one's worth full credit. But if this one came up on a multiple choice, it would definitely be written out as simplified. Like so. This is the other direction. I'll give you the ellipse. You tell me the equation. All right. Question on that example. All right, so the last one I want to deal with. Back to the whiteboard. Which is the ellipse. Sorry, not the ellipse, we just did the ellipse part. Hyperbola. Okay, so the important thing about the hyperbola is that there are 2 versions of it. One that opens horizontally, which is the one that has the x in front, which is always going to tell us that this opens horizontally like so. Or if we have y in front, that means that we open vertically. In both cases, my asymptotes are always going to have the slope of y is equal to plus or minus b over a. And those asymptotes are what we use to kind of draw in our graph. I do ask you to graph one by hand. Let's work one of those out in full. I have y on here. Second one. So, we know it's a hyperbola because we have a minus symbol. The second you see a minus in between your y's and your x's, and your y's, we immediately know that this is going to be a hyperbola. We also have the y in front, so just like we said, we know that this is going to open vertically. We don't have this one set up. This one's like 99% set up. We do have to do the last step. I would divide everything through by 4. You always want that right-hand side to equal 1. That's going to give me y plus 2 squared over, well, 4 by 4 cancels out, but remember, we always want a denominator. So if you do have it perfectly cancel out, we're always going to have this denominator of 1 minus x minus 4 squared all over 4 equals 1. All right, so now we are set up to graph this out. Okay. So, first we have our center. Once again, watch out for the variables. This is my y. This is my x. So my center here happens at 4, comma, negative 2. So I'm going to plot that first. 4, negative 2. There's my center. Next, we're going to find the a value and the b value. So remember that if it's connected to y, that's b squared. And if it's connected to x, that is my a squared. That's going to tell me that a is equal to the square root of 4, and b is equal to the square root of 1. Since we know this opens vertically, that means that I want to look at the vertical component, which is going to tell me that my vertices for those two little mini parabolas are going to go up 1 from the center and down 1 from the center. Actually, you know what? Let me do that. Let me not do those red. Let me do those like these asymptotes, like my asymptotes being red. Okay, so we have those two vertices. So I know that once again, my parabolas are going to kind of go out from these vertices, right? Looking a little something like this. But in order to kind of guide me and the thing I do need to see on there, and like I said, if this is a free response question, I'll probably break this up into, you know, what is the center? Part B would be to tell me what is the slope of the asymptote. I'm going to break it down. You know, I'm going to force you to answer these questions. So for the slope, I said I was going to do it red. Once again, that's plus or minus b over a, which in this case is going to be plus or minus 1/2. So my two slopes are 1/2 and negative 1. So positive 1/2 is up 1 over 2. So from my blue, I'm going to move up 1 point over to the right 2 points. And that's going to give me my first asymptote. And then for negative 1/2, I'm going to go down 1 point over 2. And that's going to give me my second asymptote. All we have left to do is just, once again, not looking for something pretty here. We're just doing the best. I just want to see that this, you're drawing two, I can do that. We're drawing two parabola type shapes, and those parabola type shapes move out from these vertices and towards the asymptotes. And there we have our full equation. Graph and guided with these asymptotes. And yeah, this is more or less full problem here. We had to do a little bit of manipulation in the beginning to get that right-hand side to equal 1. But once we have that all set up, it's really just kind of remembering how these hyperbolas work. Any questions on that? Alrighty. Plus y squared is equal to, where am I at? Yeah, there we go, okay. So for all these, we'll do 2 examples of this, but we're looking at elimination substitution. Substitution, yeah. And some of these you can kind of go either way. Excuse me, that needed to be, pardon me, I wanted that to just be a y, not a y squared. Let me double check that. X squared was y squared equals 9. 2x squared minus y squared equals 18. Correct. Okay. So some of these you can do it either way. Some of them you really only have one option. This one you arguably could do either way. I'm going to use elimination on this one. But we have to be very careful here. We can't eliminate the y variables because y squared and y are not like terms. So instead, we are going to eliminate the x variables because these can be eliminated. They're common terms. So we need to do a little bit of manipulation here. I want these to be the same value but opposite signs. So I'm going to multiply this through by a -2 on both sides. So that's going to give me -2x squared minus 2y squared is equal to 18. And then this one we're just going to carry over as 2x squared minus y equals, thank you, -18. Thank you. Okay, so when we add down here, the x squareds cancel. These terms don't do any canceling or combination, so what we're left with here is -2y squared minus y equals 0. So here we have to do a little bit of factoring. We can factor out a y. So that's going to leave me with -2y minus 1, 0. So if we separate this out, we get the options of y equals 0 and -2y minus 1 equals 0. So we have our first possible solution equals 0. And then if we add over, that's -2y equals +1, or y equals -1/2. So these are our y values. So now, in order to finish this up, we need to find our x values. So we need to plug into one of our 2 equations. Really doesn't matter which one. So I'm just going to plug into the bottom one here. So first we're going to plug in y equals 0. So that would be 2x squared minus 0 equals 18. Or just 2x squared equals 18. And then to just finish this up, we're going to divide by 2. So x squared equals 9. And if we take a square root, we get x is equal to plus or minus 3. So from here, we get 2 points, which is +3, 0 for the first x, and negative 3, comma 0 for the second x. Okay. Now plugging in y equals negative 1/2 in for y. That's going to give me 2x squared minus 1/2 equals 18. You could work out with the fractions if you wanted to. I think it's just easier to, I'm just going to multiply 3 by the LCD to kill the fractions. So that leaves me with 4x squared, 2 times 2. Yeah, it's like doing the last step. Yeah, in terms of the plus or minus, yeah, we are separating this up into the two x values, both of which have the same y value. That is correct. So yeah, 4x squared minus 1 equals, times 2 gives us 36. So now if we add over, we get 4x squared equals 37. Divide by 4. And we get x squared equal to 37 over 4. So we take square root. And once again, we're going to get plus minus. So we get x is equal to plus or minus. You can't simplify a square root of 37, but the square root of 4 we can simplify it into 2. So once again, separating this out in terms of two answers, we have the square root of 37 positive over 2. And then the y value of negative 1/2. And our second point would be negative square root of 37 all over 2, comma, negative 1/2. All right, so there we have an example using elimination. And you can, let's see, can I zoom that all the way? There we go. Any questions on this one? All righty. All right, so let's look at one more of these. Let's just do one that requires some substitution. Okay. So in this case, we can't do elimination because if we look here, in terms of the x's, we don't have like terms, so we can't cancel out. And in terms of the y's, we don't have like terms. So in either case, we can't cancel out. So we're going to have to do substitution. Technically speaking, we can do substitution on all 4 variables. We can pick one to solve for. But the easiest one is obviously x here. That's the easiest one because all we have to do is subtract over. And we're left with x equal to, right, well, yeah, we'll write it as subtract over the negative 3y. So you have negative 3y plus 1. So once we have that, we're just going to take that and plug that in for x into the other equation. So that would give me negative 3y plus 1 squared plus 2y squared equals 6. Here we are going to have to do a little bit of factoring. Excuse me. Foiling first, then factoring. So foiling this out, that's negative 3y plus 1 times negative 3y plus 1. So if we work that out, that gives us, just kind of working out, foiling, and technically we have the rest of this. So we got 9y squared. Outside term is minus 6y. Inside term, excuse me, minus 3y, pardon me, minus 3y. Inside term is minus 3y plus 1 plus 2y squared equals 6. So if we combine like terms, 9y squared and 2y squared gives us 11y squared. The minus 3 y's would give us minus 6y. And then lastly, we have plus 1 equals 6. Okay, so we have a quadratic. Subtract over to zero it out. And then here, once again, it's kind of whatever you want to choose. We can try factoring. We can try quadratic formula, whichever one you prefer. I think I've already done. Yeah, I've already done factoring today. Let's do a. I do. Let's see. Have I done factoring today? I could have sworn I did. At some point, did I do a diamond? Yeah, all right, we did factoring. Let's do a quadratic formula. So quadratic formula, so it would be what? Y is equal to negative b plus or minus the square root of negative 6 squared minus 4 times a times c all over 2a. All right, so just finishing this up, what do we get? Y is equal to 6 plus or minus. So that's, what's that, 36 minus minus gives us plus, and that's 4 times 11 times 5. That's 20. 16. Yeah. All over 22. So just kind of fitting this up. And taking that square root. We have 6 plus or minus 16 all over 22. And once again, anytime this square root is a nice even whole number, like what we got right here, technically it means you could have factored this out if you wanted to. I'm just doing both examples so we can practice with everything. Okay, so then from here, we're just going to split this up. 6 plus the 16 over 22, 6 minus 16 over 22. All right, so 6 plus 16 is 22 over 22, so that gives us our first answer, a positive 1. 6 minus 16 gives us negative 10 over 22. If we simplify down, that'd be negative 5 over 11. So we have our two values for y. Positive 1, negative 5 over 11. Okay, so we're going to go back here. We had this equation. We need to find the x values We can just plug both of these into the equation that we have solved for, which is x is equal to negative 3y plus 1. So here we have x is equal to negative 3 times 1 plus 1. So what is it? That's negative 3. That's negative 2. So there's my first point, negative 2 comma 1. And then here, you can either do the fraction or decimal. I'm going to keep the fractions here. We have negative 3 times negative 5 over 11 plus 1. Well, that's 15 over 11 plus 1. If we do an LCD here, we have an LCD of 11, so 15 over 11 plus 11 over 11 gives us 26 over 11. So that's my second point. Oops, that was positive 26 over 11. Negative 5 over 11. Boom, done. Alrighty. Questions on this example, anybody? Let me take a second, kind of zoom out. Yeah, there we go. Full problem on here. All right. Yeah. Any questions on this? Great. Last bit, chapter 12. We only really looked at two sections, so the only thing we're really looking at here is the sequence series stuff. And the binomial expansion, that's really it. Basically, that stuff we looked at on Monday. So just a couple quick examples. Given a sub n is equal to 3 times an minus 1 plus 2 and a1 equals 5. Find the first four terms. So we have this formula. Oops, yeah, 3 times. What this means, this an minus 1 is what we call the recursive sequence, and this just means the term before. So we have our first term given to us, so we're only looking for the first four, so we have a1 equals 5. Scooch this up just a little bit. Whereas, so a2 says we take 3 times something plus 2. Well, what that something's going to be is the 5 from the previous term. So that's going to be 15 plus 2, which gives us a total of 17. A3 is going to be, well, 3 times something plus 2, and that something is going to be the last term. So that's 3 times 17 plus 2. 3 times 17 is 51, plus 2 gives us 52. And then lastly, A4 is going to be 3 times something plus 2, where once again, that something here is going to be given by the last term. So we have 3 times 52 plus 2. That's what? 150, 156. Oh. Oops, pardon me. This should have been, pardon me, 53. I said 50. I said 52 plus 2, and I said 53, and then I wrote down 52 for some reason. Excuse me. So then we have 3 times 53 plus 2, which gives us a total of 161. So those are the 4 terms of the sequence: 5, 17, 53, 161. Okay. Question on this one. All right. So that's technically a sequence. When we're talking about a series, we're just talking about a sum of things, so that we could use the symbol for the sum notation. What do we have? 6k squared minus 4k. So remember what this says. This tells us that we're starting off at the 4th term, and we're going up to the 7th term. So we need A4, A5, A6, and A7. We're going to find out what these terms are, and then once we find them, we're going to add them all up. So all we're going to do is take these values here, plug them in for k. So that'll be 6 times 4 squared minus 4 times 4. So that's 6 times 16 minus 16 gives you a total of 80. And then all we're going to do is swap this out. Next one, we're going to be plugging in 5. So that's 6 times 5 squared minus 4 times 5. Which gives you a total of 130. Keeping this going. 6 times 6 squared. I'll keep color coding. 6 times 6 squared minus 4 times 6 gives you 192. And lastly, we have a 7. 6 times 7 squared minus 4 times 7. And check that in a calculator, and you get out 266. So last step is to just add all these up. So 80 plus 130 plus 192 plus 266. Gives you a grand total of 668. So that's the answer here. So there we have a series. Question on that, anybody? Ready. Last example. Binomial expansion. Okay, expand 2x minus 5 to the fourth. Okay, so working this out. So there are basically two things that are going on here, which is one, we have to worry about the powers of my individual pieces, so 2x and 5. And the other part is we need to worry about these coefficients. So what I'm going to start off with is I'm just going to start off by just writing out my powers of these two pieces. So we're going to start off with a 2x to a fourth power. And we're going to end with a negative 5 to the fourth power. And then what we're going to do is we're going to keep going down powers of this. So the next one's going to be 2x to the third. Give yourself a little bit more room. Then if we go here, we're going to have 2x squared. Then 2x to the first. And then technically we would have 2x to the 0, but the 0 just drops off. And then on the other side, well, counting down here, my next one would have negative 5 to the third, negative 5 squared, negative 5 to the 1, and then the last one would have negative 5 to the 0, but that one drops off. Okay, so the last thing we're missing to finish this up and then just kind of calculate everything is we need these coefficients. And those we get from Pascal's triangle. Or if you want, you could use the NCR formula. But in general, we just start off with a triangle of ones. I'm going to do this. I'm going to slide this down. Actually, give myself a little bit more room here. I'm just write my triangle one. So we start off with a row of ones, and then remember we take these two, add them together to get what's in the middle. And then outside row of ones, 1 plus 2 gives us 3. 2 plus 1 gives us 3. Row of ones, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And we just hit the power that we were looking for. We have that fourth power. So we hit that 4 on that second term. So that tells me that my coefficients here, if I plug in, will be 1, 4, 6, 4, and 1. Okay. Oh, sure. These are the individual pieces. Are there any questions on this? Because this is kind of the hard part. This is the theory part. If you understand this part, everything else is just doing powers and numerical calculations. There's not much else to this. This, I would say, is kind of the hard part. Okay. Alrighty then. So now we're just going to work out these powers here, right? So that's going to be 1 times 2 to the 4th is 16. X to the 4th. Now I'll just write it here as a plus for right now. So we're going to have 4 times 2 to the 3rd is 8x cubed. And we're going to multiply this times a negative 5. Plus, here we have 6. 2 squared is, oops, wrong color. 2 squared is 4x times 25. Negative 5 squared is positive 25. Plus, we got 4. 2x to the first power just gives you 2x. And negative 5 cubed gives you negative 125. And then lastly, we just have plus 1 times 5 to the 4th gives you 625. So now we do is just multiply all this stuff together. So we've got 16x to the 4th. Here we have 4 times 8 is 32, times a negative 5 gives us negative 160 x cubed. 4 times 25 is 100, times 6 gives us 600 x squared. I just realized I forgot to put my little squared on here, excuse me. 4 times 2 is 8. 8 times 125 gives you negative 1000x. And then lastly, plus 625. So here we have the full expansion. And here I did the full thing on an exam. I might not ask for the full thing. Maybe I only ask you to give me like the first 3 terms of expansion. So just be aware of that. This one wasn't so bad. If I did something that was a higher power, like a 5th or a 6th power, maybe that's something where I'd only ask you to do like the first 3 terms. So it's enough so I get the idea that you know what you're doing without having you to just kind of kill you with just unnecessary busy work. Okay. Questions on this example, anybody? Okie doke. I will stick around as always if people have other questions for me. If not, have a lovely evening. And I will see you guys next Monday for the exam.